Okay, so to start the transformations of graphs, I want to look at first just the parent functions only. And this is kind of just some helpful info, some graphs that you should remember off the top of your head how they look and their coordinates and everything. So the first one is called the identity function. And we'll call it f of x is equal to x. So here's your x-axis and your y-axis. All right, and you can plug this in your calculator and see what it looks like. But this is all of these examples you can plug in the calculator, but it's good to get to know them, to know what they look like, and it will help make some of the transformation of these graphs easier. So this is the only one I'm going to do this on. I'm going to draw a t-chart to graph all these, but after that I'm just going to draw them. So you have x, and then you have your y value, f of x. So if I plug in 0 in here for x, and I'm going to write this out one time too, f of 0, that means I plug 0 in everywhere there's an x, so I get 0. So that point is 0, 0. All right, remember, f of x is the same thing as y. Now if I plug in, if I use x equals 1, that means I plug 1 into this function, so I get 1. And then I plug in 2, and I get 2. Hopefully you see the pattern there. If I plug in -1, then I get -1. -2 is -2. So this is just a straight line, and that's why it's called the identity function. It's whatever you plug in, you get back out. And you don't need this many points to graph it, but that is your f of x identity function. All right. Next, we're going to have the quadratic function. Here's your x-axis and your y. And it goes through the origin of 0, 0. Excuse me, I'm going to write. It's g of x equals to x squared. Sorry about that. So when I plug in 0 in here, 0 squared is 0. That's how I get this point. Then I plug in 1. 1 squared is 1. And then I plug in 2. 2 squared is 4. 1, 2, 3, 4. And if I were to plug in 3, 3 squared is 9. So it put a point up here somewhere. And then we go to the negative side. If I plug in -1, -1 squared, it's -1 times -1, which is a positive 1. And I plug in -2, -2 squared is -2 times -2, which is also 4. And then if I plug in 3, I get positive 9. So, looks something like that. It's an upside down, it's a cup, basically. Looks like a U type. All right. And so, the reason I'm showing you these graphs, and I'm going to show several more, is we're going to want to transform these graphs into something else. But if we know the parent functions, and we know how to read the function that's given, then we can transform the parent function into whatever we're looking for. And that'll make a little more sense when you look at examples. The cubic function. All right. And x-axis, y-axis. The cube has 0, 0, 1, 1, -1, -1, and then it will have 2, 8, and I'm just not going to run out of room there, and then -2, 8. And I keep forgetting to write the function for you, but it's x cubed. So 0 cubed is 0, 1 cubed is 1, and then 2 cubed is 2 times 2 is 4, times 2 again is 8. So that would give me a point up here at 8 for 2. And then a -2 would give me a -8 down here. And that is h of x. See, next is the square root. Which we'll label as m. That's equal to the square root of x. I have my x and y axis here. Then x equals 0 gives me the square root of 0, which is 0. X equals 1, the square root of 1 is 1. And then 2 gives me the square root of 2 is some decimal. The square root of 3 is some decimal. The square root of 4 gives me 2 though. And then the next one would be 9 and 16 and 25 and so on. We're just going to stop there. That gives me m of x. And then we have the absolute value. We'll call this one a of x. Which is just two vertical lines. It's a vertical line on each side of the variable. And its graph looks like this. Let's see here. 0. The absolute value of 0 is 0. The absolute value of 1 is 1. Absolute value of 2 is 2, and so on. So to this point, this is the same as the identity function. What's different is when you get to the negative side of things. So when you plug in -1 into an absolute value, it changes it to a positive. So it just takes the positive of whatever value is inside. And then -2 gives you 2. -3 gives you 3. -100 gives you 100. This is a of x. And so I needed to mention over there, I did the positive x values. If I try to plug in -1, I can't take the square root of a negative number. So I don't worry about anything on this side. You can, it's imaginary I, and we're not going to get there, at least right now.